Hello everyone, welcome to Artec 3D YouTube channel. My name is Ilya Morozov and I'm with Artec 3D. I'm an application engineer and training specialist here. And today's content, well, as you could probably guess from the setup, we will be scanning this mechanical part. Let me show it to you. This beautiful, beautiful piece of German automotive industry. This is a mechanical steering rack, and today we will be scanning this object with Artec Leo. I will show you some strategies on how to prepare your object, how to scan, how to process, in a way that the object will be ready for further inspection if you're scanning for quality inspection, for example, in software like Control-X or Zeiss Inspect. Alternatively, you can use this object to demonstrate on your website, you can use it for reverse engineering, etc., etc. But today's objective, again, is to scan this object. That's what we will be doing. What is special about this steering rack? This steering rack is it is a thin object with not a lot of texture, meaning that is basically like almost only gray color. And the fact that this object is thin, it poses some not actually problems, but let's say some minor technical inconvenience that can be solved pretty easily thanks to our software Artec Studio. What I noticed from our users, even sometimes from our partners, is that when they are trying to scan the object like that, they are sometimes very creative with the setup. They put the object on some like thin racks to have it like that, or some even fix it from above, like using some like chains or ropes. And I mean, this approach seems pretty logical. So less background, less auxiliary objects you have in the field of view, easier you will be scanning, less object you will need to erase, and so on. It seems like that, but it's not really like that. So what's the problem here? So if you want to scan like a pro, you need to think of how this object is seen by Artec Leo. And Artec Leo sees this, for example, this area or this area as a pretty complicated featureless area. So, as a matter of fact, when Artec Leo scans, it takes photos of the object. So, as you know, Artec Leo doesn't use any scanning targets. Instead of scanning targets, Artec Leo uses the own features of the object. And as you can see, the problem here is that when the Artec Leo scans this area, like from this angle, it sees only, it takes a bunch of very, very similar photos. And after that, Artec Studio has not a very great time when processing it. But fortunately, this issue could be resolved pretty easily, and I will explain you how to scan this object like a pro. So first of all, in order to give Artec Leo better referencing, we will add some additional texture on our table. It is pretty easy, to be honest. I will use just some pieces of paper with markers. So I used like a regular liner, and I draw some pretty spontaneous parts. You can draw waves, crosses, lines, even letters, like whatever you want. The only thing that you need to be aware of, just make sure that the lines are thick enough so Artec Leo can easily recognize them. So I will add here, here also. Yeah, and elevate the part is really important. I will tell you on the processing part why it is so important. And basically this setup now is ready. And now when Artec Leo scans this part, it will see not only a part of this metallic bar, but it will also see these characters, these lines, crosses, and it will be really easy for Artec Leo to recognize these these characters. And positioning of frames taken by Artec Leo will be done by using not this area, but this area, which is like pretty feature rich. You may ask, like, is it really necessary to add texture? Can I add geometry? Well, generally you can add like additional geometrical objects, no problem with that, but texture is generally easier, and on our algorithms, texture has a bit higher priority compared to the geometry. Alternatively, if your table is like wooden, so it has this texture of the wood, in this case you don't even need to come up with these pieces of paper. Actually, wooden surfaces, they are pretty good with with adding additional texture to the scene. So what I need to do, I need to add some spray. I'll use ASAP, but to be honest, you can use pretty much any of them. I will spray like these shiny parts because this steering rack is quite new, so I will put some spray. Also, the black part I also will spray, just because before recording this video I checked it, and I found out that black area is, I mean, it is recognized but not as good as I would like to, so I add some spray too. Not too much, you don't need to like paint it. You just need to make sure that you don't have that your object is not shiny, and basically you are on the safe side. And I can basically, I'm ready. There will be, this position will be the first one. Totally, I will take the scan in 3 positions, and then I will combine them into one mesh in Artec Studio. It is possible to do that. I will show it to you in the second part of this video with the processing. Regarding of the Artec Leo settings. So if you are aiming for higher accuracy, you can enable the function which is called temperature control. Today I will not be using this feature. Regarding the resolution, since I want to catch the tiniest details, I will use ultra resolution, but you are absolutely allowed to use normal resolution if you are not aiming to scan like really tiny parts. And please do not enable base removal, okay? Because at this point I actually need the base, because the base provides the vital texture that is really needed for my future processing. So, ready to scan, and I am scanning. Well, as you know, the Artec Leo is pretty fast scanner, so you can scan and move pretty rapidly. One thing about scanning, which doesn't, it's not really about scanning the thin object, but rather about scanning holes. So as you can see, I have two of them here, and I need to scan them. And in order to do that, I will be pointing my scanner to 45 degrees. Why am I doing that? Because, I mean, you cannot really scan a hole, because a hole is, I mean, like, philosophically, hole is rather the void, like the absence of anything. And I will be focusing on scanning the inner wall of the hole. And in order to do that, I need to keep the scanner 45 degrees. And I am not losing tracking at all, because because why? Texture is really great. It is keeping the stable tracking, and I am sure that the registration will also not pose any tiny technical problem here. There's no specific trajectory that I would recommend. Just go around the object, changing the angles, moving your wrist, and making sure that you scan everything that you could have scanned. Right. If I didn't scan anything, that's okay, because the things are not exposed in this setup will be exposed in the second setup. And that is why having several scans is actually, it is a safe strategy, because it increases the chance that everything will be scanned. So I will check my object. Pretty much anything that I wanted to scan, I scanned. And now I need to change the position of my object. So the second position will be like that. Again, some spray. Because, I mean, there's no spray on this part. Let me do it. Again, if your object is quite old and it's not shiny, you probably can totally skip the spraying part. I'm doing that because, as I said in the beginning of this video, this part is brand new, and yeah, surely these surfaces are freshly polished, and scanner is actually not it's not seeing these parts very in a very good way. So let's add the second scan to the same project. Regarding the setup, you can leave it as it is. The fact that the texture characteristics are the same in the same position will not ruin your object. I will show you why. So actually, the strategy for the second position and for the third, and actually for any position, is the same. I am scanning the object, hiding the texture features in the field of view, and just making sure that I capture everything. And how do I make sure? I use as many scanning angles as I could. Yeah, just make sure that the tip of your object is well scanned. It will help you with the further registration, and the model will be looking quite solid. Right, and the third position, obviously something like that. Don't worry if some of the areas of your objects are touching the ground. Of course, some part from this scan will be deleted when we erase the base, but it's actually okay because I have everything scanned on my first scan, so I really don't worry about that. And you shouldn't be worried about that as well. Yeah, and surely it is way better to scan this type of the object, meaning the object that is quite thin, using the HD mode, because HD mode is capable of delivering quite sharp details, quite good results, and so on. I'm not spraying this in this setup because I actually sprayed it before, and I have everything pretty much sprayed, so no problem with that. So that's pretty much it. I scanned this part in 3 positions with additional texture, and whoops, the fan of Leo is pretty cool. So as I said, everything is finished now, and I checked the scans on Artec Leo screen. Apparently I scanned everything, but if not, I'm always allowed to go back and take another scan of the area that I hadn't scanned before, so really no problem with that. Well, that's, I guess, pretty much it. What you need to know about scanning thin objects with Artec Leo. Well, first of all, you need to use additional texture on the background. And second, you need to elevate your objects from the textured background while keeping the texture in the field of view. And the rest I will show you on the second part in the processing. I will show you how to manage this data properly and receive a really good and detailed mesh. See you. So welcome to the processing part. As you can see, I have already transferred the data from my Leo to Artec Studio. These are my scans, but I will not be working with them because these scans that you can see now on your screen, these scans are SD scans, and I will be working only with HD data today. So what I need to do, the first step is to mark all raw HD data and go to HD scan reconstruction. I will use the default settings with the point density ultra in order to preserve as many details as I could. So yeah, let's wait a bit. All right, this is the HD data, and this is exactly the data that I will be working with. So first of all, I will go to editor and I will delete these supporting parts, but I will delete only them so far. So I will preserve the rest of background where I have the additional features. So I'll go to eraser, and I will basically just erase these supporting pads. If you are afraid of deleting the parts of the objects, well, don't worry about them, since you, and I mean me in this case, since I have scanned the object in several positions, I will probably have the data, the data that will be deleted on one scan will be present on the second or third scan. So if you delete like a little bit of the object along the way, so that's perfectly normal. Don't worry about that. All right, this one is ready. Now the next one, the logic is the same. I mean, it is just, it will be easier for me to align without these pads. So yeah, please don't delete the background so far. Yeah. This one as well. And the third position, here I will do exactly the same thing. So hopefully I have the rest of these connection points of the steering cracks on my first and second scan. I'm pretty sure about it. So, right. Now we have prepared our scans for the alignment. What I will do, okay, I will align them one by one. I'll go to scan color to have better color differentiation between them, and I'll go to align. And now, yeah, please, the piece of advice from my side, please don't try to use auto alignment here, because since I used generally the same background for two positions, there's a high chance that the features from the background will be taken for the alignment. And that is something that I would like to avoid, because my alignment should be done based on the object and not on the background. So let's try now. You don't need to be super precise when placing the connection points. You just need to place the connection point in more or less the same area, and the algorithm will fine-tune your alignment by itself. So as you can see, the part is aligned, so I will probably replace this scan here, and I will create a group. And in this case, when I will be aligning with the third scan, I will have not three but two objects. One group that is aligned as one object, and the third scan that I am about to align now. Okay, now this one should be easier to align because I have pretty much everything covered. this. And that one here. Right, even though the positioning, it wasn't that perfect, as you can see, the algorithm is pretty capable of fine-tune your imperfect alignment by its own with a very, very precise results. So the alignment is done, and the next step is the editing again. I need to edit my object now, but here here I will show you how you need to edit in order to get the perfect registration in the further steps. So what I will need to do right now. So the logic here is that I will leave the background with the texture for further registration. I'm allowed to do that, but the only thing that I need to do before is that I need to make sure that these backgrounds do not intersect with each other. And in order to do that, I need to delete basically all the cross sections. So I will go to the editor. I will delete this cross section. Well, probably, yeah, no intersection here. This one as well. This. And now, so I need to make sure that I delete the intersection, but without deleting this part of the object that I actually need. So how I will do that? I will yeah, I will delete this part of the background using 3D brush. This one is somewhat more precise. Yeah, I don't need this part as well. This I don't need. The same I will do with the third scan. So I deleted a part of this bar, but I do not worry because I have this exact part scanned on my previous scans. Okay, probably delete a bit here as well. And now let's see what I have. Well, what I can do now, in order to make sure that I don't delete any necessary part from this area, I can mark this part and I will use the tool, the pretty cool one I will show you. I will use the tool that is called hide. I will hide this area, and in this case it will be preserved, but it will not be deleted when I delete the area nearby. So that thing gives me the possibility to make a pretty wide selection and delete it. So show, and you can see that this part is here, like nothing happened. Okay, this, and generally my setup is ready. You can see that there are no intersections, and my scans are ready to be registered. I'll go to Tools, Registration. I'll probably increase the keyframe ratio to 0.6. And here's the thing. Why I needed to delete the intersection parts. You see, here is the parameter search features within in millimeters, and generally this is the radius of a sphere where the Artec Studio will be looking for the same features. And the problem with intersections, especially when these intersections are from the same background, is that they will inevitably be registered one to another, and we really don't want to have this kind of registration. So that's why I deleted all the intersections, and I can be sure that this part of the background, this gray one, will not be registered with this one, because the distance between these backgrounds is more than the search distance. That's why I can go and click on Run. And I'll need to wait for the registration to finish. As I said, I changed only keyframe ratio because yeah, 0.6 will give me better results. But okay, anyway, you can choose based on your experience and based on your particular object. And even though my object doesn't have a lot of texture, the background has, so please leave here geometry and texture as features for registration. In this case, you can be sure that all the texture features are taken into account. So here is the result. As you can see, this is before the registration, this is after the registration. The intermixing between the scans is absolutely beautiful. I love it. And the registration result is actually pretty good. So I have only here some 3 error frames, and this error is caused by the absence of the surface, which is totally okay. This frame is, this one has the biggest error. This one is also not very good in terms of the surface, so I will probably move it to new scan just in case. And yeah, generally this is the last step when I actually need the background. After registration is done, you can safely delete the background from your object, and that's exactly what I will do. Again, if you think that lasso selection or rectangular selection will do a better job here, I have no objection with that. I mean, the 2D selection is my personal preference, but it doesn't mean that it is better than other options. It's just my preference. So you are absolutely free to use any type of selection. It doesn't really matter here. It doesn't affect the workflow. Okay, maybe this one, just in case. Okay, and now I have pretty much everything. So, okay, there are some remainings. I will delete them too. Okay, and now I can finally run the fusion algorithm. Yeah, I will go with Sharp because this is not combined project and this is the project in HD, so the Sharp is the type of fusion that we recommend. I'll do watertight, and generally the error value is quite low, so I will not be installing any threshold, and HD medium sensitivity is also a good option. 3D resolution 0.5, I think it also is okay for HD data and for this type of error. Anyway, let's see. Mesh optimization, triangle quantity, I will cut in half. Heal bad polygons, yes. Okay, and this is finally my part, my mesh. As you can see, this is the mesh object. Um, the mesh I received, the mesh is very detailed. As you can see, there are even tiny objects that are easily recognizable. And yeah, that is actually it. So yeah, there are sometimes the artifacts which can be tackled pretty easily. I will use the feature brush. Yeah. And this is actually the level of detail that Artec Leo is capable to deliver. So, what we can do with the object itself in Artec Studio. In Artec Studio, we have a quite simple but yet pretty useful toolset dedicated to measurements. And so this toolset is generally capable of extracting some basic measurements, mostly by fitting primitives. So I will do that right now. So I will, let's say I need to know the diameter of this area. So I need to go to construct, choose a cylinder, mark the area, fit cylinder, and I'll go to the cylinder's properties, and I can see that the radius is 8.78, and this measurement is actually quite accurate. You can check it using the caliper or any other measurement device. What else? So aside from the radius measurement, I can do other types of measurements. So, for example, let's uncheck this one, and for example, I can fit two planes here, and I can go to measures and measure the diameter between them. By clicking on them, you can see that here I have the perpendicular line, which has the respective icon here, and the distance between these two planes is 13 millimeters. Um, yeah. Generally, the um, The measurements are limited by the amount of primitives, by the types of primitives. So generally the idea is that you can extract some measurements here, but for more advanced tools like reporting, angle measurement, and so on, you can use the third-party software such as Geomagic Control X or Zeiss Inspect. In these tools, you are capable of creating the report, providing quite complicated measurements, and etc. The last thing that I wanted to cover in this video is that, well, as you can see, the position of this object is quite random in the space. So if I go to left, well, it's not really, I mean, it is aligned, but sometimes it is aligned not in the way that you would like it to be aligned. So how to align the mesh object with the axis that you have here? So first of all, again, we need to go to construct. I will use this area and I will fit in a cylinder here. Yeah. What else? I can see that this part is pretty well positioned. I mean that this cylindrical area should be 90 degrees to this area, and I will create a cylinder here as well. And I will make them, I will apply constraints. I will make this cylinder perpendicular to the second one. Refit. And now you can see that this cylinder has the respective icon that shows me that this cylinder is constrained to another one. Why I need to do that? Because I will now use these two cylinders for precise positioning, for so-called precise positioning. I'm not able to execute the precise positioning without fitted primitives. So I go to Editor, Precise Positioning, and now I have two cylinders, and I will be using their axis to align them with the axis that I have here in the navigation cube. So first of all, I will move this cylinder to origin. I will align this cylinder to Y, and thanks to the fact that this cylinder is perpendicular, I will align the third, this cylinder number 3, with X axis. And you can see that cylinder 2 is aligned with Y and cylinder 3 is aligned with X. And that's how I have my mesh fully aligned. And this may be a quite useful tool, especially when you plan to transfer the mesh to the third-party software. So in order to not to align the mesh in the third-party software, you can fully prepare your object here in Artec Studio. That's basically it that I wanted to show you today. As you can see, Artec Leo is capable of scanning even quite complicated objects, and Leo is also capable of preserving fine details on quite decent level. So good luck with your scanning, and if you have any questions, don't hesitate to ask our support team. We will leave all the contacts in the description of this video. See you. Bye.